Last class, we were working on example number 9. Given two different points on a straight line, how do we find the slope of the line? Two different points determine a straight line, and we are able to find the slope of the line using the coordinates of the 2 points. So we introduced the 2 methods, right? Yeah, we're going to use the 2 methods to solve number 2 here. The first method is algebraic method. I come up with another way. We can put one point above the other. Okay, it doesn't matter which one on the top, which one on the bottom. But once you place them, you have to keep the consistency. Yeah, like I put 92, 94 above 0, 2, then I have to keep the consistency. Slope is changing y over changing x. So what I would do is I'm going to use, this is the y value, this is x value, right? I'm going to use the first y value minus the second y value. So slope equals parentheses minus parentheses all over parentheses minus parentheses. In the numerator, we put the first y here, second y here. In the denominator, we put the first x here, second x here. All right? And then we evaluate. Numerator, 94 minus 2, negative 6. Denominator, 92 minus 0, negative 2. When both top and the bottom are negative, the negative signs are cancelled. So we have a positive 3. The slope of the line passing through those 2 points equals a positive 3. That's the first method. All right, I think this method is pretty neat. Remember, slope equals a ratio. In the numerator, we have parentheses minus parentheses. Denominator is the same thing. And how do we plug in those 4 values in the 4 parentheses? We place the 2 points vertically, okay? And then we do the numerator. The numerator gonna use y value. Do you have any questions? Okay, so we use the first y value, put the first y value here, second y value here. And the denominator, first x value, first parentheses, and the second x value, the second parentheses on the bottom. Kaylin's here. Hi, Kaylin. Okay. Later I'll change the attendance. Thank you for coming. I think we have 2 more. Tevin is here as well. I need to remember that. Second method, we use graphing method, right? Let's draw the rectangular coordinate system. And plot the 2 points. The first point, negative 2, negative 4. In quadrant 3. Second point is 0, 2. Remember, how do we use the graphing method to find the slope? We connect the 2 points. And then we construct a right angle triangle, like this. This is right angle triangle. And we label one point as A, the other as B. It doesn't matter the order. Yeah. I consider from A to B. Like we move from A to B. Slope is rise over run. From A to B, rise is a positive, right? Because from A to B, we are getting higher. Yeah, we go up. Yeah, how many units up from A to B? We can count it here. See, 1, 2, 3, 4, 5, 6, right? Yeah. So rise 6. Run from A to B. We go from the right. We go from left to the right. So the run is also positive. How many units to the right? 1, 2, right? So rise over run. 6 divided by 2. We got a 3 as well. So that's the graphing method. Yeah. The answer is 3, right? Yeah, 6 divided by 2 equals 3. Very good. And what if I look at the 2 points? I decide to move from B to A. Would that work? Yeah, let's see what happens if I go from B to A, this direction, okay? This time I'm going to go from B to A, go down. Then slope is also rise over run. Slope is rise over run. From B to A, I'm going down. So the rise is a negative, and negative 6. From B to A, horizontally, I go to the left. So the run is a negative, negative 2. While negative 6 divided by negative 2 is also positive 3. Correct? All right? Yeah, so that's the second question. Makes sense. Okay, thank you, Jill. And let's look at the 2 questions. One question we covered the end of Monday. The second question we just covered just now. Yeah, I'm going to graph the 2 straight lines simply by extending the line segment. This is a straight line whose slope equals negative 2, my bad. Yeah, this is a straight line, the red one, whose slope is negative 2. Slope is negative 2. And this is a straight line whose slope is a positive 3. Positive 3. Yeah. Let's look at the 2 straight lines. This straight line is a straight line declines or goes down. Yeah, how do we understand a graph? Same way as when you read a book or read the information on your phone, you go from the left to the right, right? You are not be able to read it if you go from right to the left. Same thing, when we read a graph in algebra, we follow the same order. We look at the graph from the left to the right. If we look at the graph from left to the right, the line goes down, right? Yeah, the line goes down. Turns out this declining straight line has a slope negative. And this straight line, if we look at it from left to the right, it rises, right? It getting higher, yeah, goes up. It turns out this rising straight line has a positive slope. Yeah, is that a coincidence or, just for those 2 cases? It is actually a general truth. Any straight line, if the line goes down, declines, the slope is negative. Vice versa, if a straight line has a negative slope, the line goes down. If we have a straight line goes up, rises, then the slope is a positive. If the line has a slope positive, then the line goes up. So those are actually 2 important conclusions. Let me repeat the 2 conclusions. We have 4 in total. Yeah, those are the first 2. The first conclusion, if we have a straight line goes down, the line has a slope negative. Vice versa, if we know a straight line has a slope negative, then the line goes down. Second conclusion, if we have a straight line goes up, rises, then the slope is positive. Vice versa, if the slope is positive, the line rises. Okay, always is a general truth for any straight line. So when you work on your assignments or tests, and if you have the graph of the line, it is declining, and you end up with getting a slope positive, that means your answer definitely is false. Your answer is wrong. Okay, because if the line declines, if it's going down, then the slope must be negative. And let's work on number 3 and number 4 now. Let's use the algebraic method. All right, yeah. So I'm gonna put one point above the other. I put a 0, -4 above 5, -5. We are looking for the slope of the line passing through those 2 points. This is the y value, this is the x value. And we know slope equals parentheses minus parentheses all over parentheses minus parentheses, right? Yeah. In the numerator, I'm going to use this value minus this value. So the first y value go here, second y value go here. In the denominator, first x value go here, second x value go here. What is 95 minus 95? Yeah, please do not overthink. Any number minus itself is 0. Yeah. Don't get confused by minus negative. It's actually 95 minus itself, right? Yeah. You know, 95 minus itself. 95 minus itself is 0, right? Yeah. Very good. Thank you, Joe. Is 0. And the denominator, 0 minus 5 is 95. Question, what is 0 divided by 95? Your calculator would be able to tell you. 0 divided by 95 is 0, all right? Is 0. Turns out the slope of the line passing through those 2 points have a slope of 0. Let's see what kind of straight line that is. Let's plot the 2 points. First point, 0, 95. 1, 2, 3, 4, 5. Right here. Second point, 5, 95. 1, 2, 3, 4, 5, 95. Yeah, and then we connect those 2 points. We got a horizontal straight line, right? Yeah. This horizontal straight line has a slope of 0. This is going to be our third conclusion. Any horizontal line, in fact, any horizontal straight line has a slope of 0. That makes a perfect sense because the straight line is flat, right? Yeah, the straight line is flat. It does not go up. If it goes up, slope is positive. It does not go up, so slope is not positive. It's flat, so it does not go down. If it goes down, then the slope is negative. Since it's flat, it does not go down, slope is not negative. When the slope is not positive, not negative either, it has to be 0. So any flat horizontal straight line has a slope, okay? 0 has a slope of 0. Has a slope of 0. Vice versa, if we know a straight line has a slope of 0, now we should know that straight line is flat. Okay, do not go up, do not go down. The slope is a horizontal straight line. So that's the third conclusion. Let's continue. We have one more to go. And we use the algebraic method. Okay, I put 1 point on top of the other. It really doesn't matter which one on the top, which one on the bottom. You will result in the same answer. And then slope, remember, equals parentheses minus parentheses all over parentheses minus parentheses. Okay, again, numerator is y because it rise, right? Rise over run. So the numerator is a change in y. So we look at the second component. We put the first y value here, second y value here. In the denominator, we put the first x value here, second x value here. 0 minus 92. What is 0 minus 92? Positive 2. Very good. Minus negative is the same with the plus positive. Yeah, let me explain here. I think it's a good point, good point to stress. Do you remember I mentioned opposite? When you place a negative sign in front of a quantity, you got the opposite of the quantity. So how do you understand this notation? You can understand that as the opposite of 92. What's the opposite of 92? Positive 2, right? Yeah, so that's my way to see the structure. One of my ways to see the structure. This is the opposite of 92, which is positive 2. Or another way you see it is you can see this as 91 times 92, right? You don't see the 1 here, but actually it's 91. 91 times 92, you got a positive 2. Because negative times negative is a positive. Yeah, either way. So the numerator is a positive 2. What about the denominator? What's the denominator? 2 minus 2. Yeah, we all know 2 minus itself is 0. Okay, question here. What is 2 divided by 0? What is 2 divided by 0? It's actually not 0. If you try use your calculator, yeah, you can try. Use the calculator. Yeah, undefined. Thank you, Jamie. Yeah. If you use your calculator to divide 2 by 0, your calculator will tell you error. You know, let me try on my phone. I don't know if what's the answer the phone tells. Excuse me. So 2 divided by 0, error. Yeah, it tells you error. What does that mean? It means the denominator cannot be 0. This value, this number is undefined, does not exist. Yeah, undefined. Vertical straight line does not have a slope. In other words, vertical straight line. Oh, how do we know it's vertical? Sorry. Let's graph it. 2, 0 is here. And 2, 92 is here. They're collinear. Connect them. You got a vertical line, right? Yeah, they are. The 2 points are on a vertical straight line. Yeah, this vertical straight line does not have a slope. It's undefined. Okay. In fact, any vertical straight line slope is undefined. Vice versa, if we know a straight line whose slope is undefined, then the straight line must be vertical. So that's our number 4 conclusion. Number 4 conclusion. One thing I want to point out, a common mistake is about the horizontal straight line. Slope of a horizontal line, it exists, okay? Yeah, a horizontal straight line does have a slope. It's just the slope value. The value of the slope is 0. Slope equals 0 doesn't mean it does not have a slope. Only vertical straight line does not have a slope. Okay? Yeah, it's something you need to memorize very accurately. Yeah, the common mistake is slope is 0, horizontal line. That means doesn't have a slope? No. Slope does exist for horizontal line. It's just the value of the slope equals 0. Okay? Value of the slope equals 0. So those are the 4 conclusions. We have the 4 conclusions summarized in this diagram, in this graph. Okay? 4 of them. Let's look at them together. Look at the first one. I'm using a blue light blocking glasses, so this one seems right now is green. Look at the green line. The green line goes up, right? The green or blue? No, sorry, this is the blue. This is green. So blue. So the blue goes up. If the line goes up, positive slope. The slope is positive. Vice versa. If the slope is positive, line goes up. Second one, the purple one. If we have a declining straight line, slope is negative. Vice versa. If the slope is negative, the line goes down. The third one, this one is green, I think. Doesn't matter. The horizontal line. Horizontal line has a slope of 0. Vice versa. If the slope is 0, line is horizontal. And the last one, the red one, vertical straight line does not have slope, or slope is undefined. Vice versa. undefined slope corresponding to a vertical straight line. Yeah, that's something I want you to memorize. All right, understand and memorize. The example we just did, example 9, we actually kind of like proved using examples. Understand why a declining line has a negative slope, because when you go to the right, when you run to the right and you go down, your rise is a negative. That makes the slope negative. But if the line goes up, you run to the right and you also goes up. Both the rise and the run are positive, so it's positive. And we also see why a horizontal line has a slope of 0, a vertical line has no slope or undefined slope. All right, very important. Yeah, it's in the class worksheet, the 4 graphs. I want you please remember that. All right. Do you have any questions about this this graph, this figure, the 4 conclusions in the figure? If we have a fraction that denominator is 0, then the fraction is undefined. Denominator it can never be 0. All right, thank you, Jill. And let's continue. Number 11. We are going to rewrite the equation in the slope-intercept form. Okay, so remember last time we learned a standard form, right? Standard form for straight lines. Standard form of a straight line look like this: ax plus by equals c. Remember that? Yeah. A, B are not both zeros. Yeah. Ax plus by equals c. That's the standard form. And today we are going to learn the second form. The second form is called the slope-intercept form. Slope-intercept form. Slope-intercept form of a linear equation in 2 variables looks like this: y equals mx plus b. Y equals mx plus b. Okay, yeah, that's something you need to memorize. Slope-intercept form is the most common used form for a straight line. Y equals mx plus b. X and y in this equation, they are the 2 variables. And what happened to m and b? M is the slope. Yeah, turns out on the right side of the equation, the coefficient of x is the slope of the line. And b is the y-intercept, where 0, b is the y-intercept of the line. Yeah, how do we know? When we make x be 0, remember, if we make x be 0, we will have the y-intercept. If we make x be 0, this part disappear at y equals b. So 0, b is the y-intercept. And the reason m is the slope, I'm not going to prove it, okay? Just memorize. M is the slope. Since in this format, we are able to tell the slope and the y-intercept directly, the name of this format is called a slope-intercept form. It's very straightforward, right? Yeah, the name tells us, the name explains the structure. Variable y by itself on the left side. On the right side, we have 2 terms. The first term is the first basic type, right? A number times a variable. Yeah. And the second term is the constant term. And turns out the coefficient of x is the slope, and the b, the constant term, is the y value of the y-intercept. Okay, yeah, so very important. We know slope-intercept form of a straight line has a variable y on the left side by itself. Okay, so number 11, we are going to rewrite those equations in a slope-intercept form. When we look at the given equations, they are all in the standard form, right? Yeah, so this question is about converting from standard form to slope-intercept form. Let's get started. Remember, slope-intercept form has y by itself on the left side. So that's the reason to rewrite the equation in the slope-intercept form, we are going to solve the equation for y. Okay, solve the equation for y. Yeah, our goal here for this question is going to be isolate y on the left. Isolate y on the left. Yeah, we are going to solve this equation for variable y. So we are going to isolate the variable y on the left. Yeah, because the slope-intercept form has variable y on the left side by itself. That's the reason. Okay. All right, let's start it. Something I need to explain. So we solve the equation for y, means we are going to treat y as the only variable. I know, in fact, we have two different variables, x and y, right? But when we solve a formula or equation for one variable, we are going to treat the other as a constant. It's kind of weird. Imagine you have the best friend, right? And your best friend is not related to you, like biologically not related to you, but you see him as your brother. Does that make sense? So when we solve this equation for y is going to be the only variable, and we are going to treat cx as a constant. That means we want 3x on the right side, so move it over. You see what I'm talking about? Yeah, the transposition of terms also works here. We have 3 terms in total in the equation, 3x plus 4y equals 9. Since our goal is to isolate the y, we are going to move everything else to the right-hand side, to the right side of the equation. As you can see, 9 stay on the right, 3x on the left is moved to the right, become a negative 3x, right? And then we divide everybody, all the 3 terms, by the coefficient of y, which is 4. Divide by 4, divide by 4, divide by 4, right? And then we have a y isolated on the left side. We have a y equals negative 3 over 4x plus 9 over 4. You see that? Yeah, now the equation is in the slope-intercept form. Y equals mx plus b. Question here. We just now converted this equation, the straight line, from standard form to slope-intercept form. Yeah, the y variable is on the left side by itself. My question here is, what's the slope of this line? What's the y-intercept of the line? Yeah, my question is, what's the slope of the line and what's the y-intercept of the line? Yeah, the one advantage of slope-intercept form is we are able to identify the slope and the y-intercept right away. Slope, yeah, what's the slope and what's the y-intercept? Once we have the equation written in the slope-intercept form, we are able to identify the slope and the y-intercept of the line directly. Would you answer that question? Yeah, what's the slope? Slope is 93/4. Very good. Thank you, Belle. And what about the y-intercept? Remember, y-intercept is a point with x value 0. So you want to give me an ordered pair, 0, comma something. What is the y-intercept? Zero, the other way around. Yeah. Joe is 0, comma 9 over 4. Okay, yeah, slope is 93 over 4. Y-intercept is 0, comma 9 over 4. The B here is the y-intercept. You see that? Any questions? Yeah, 0, comma B. So on the right side, we have 2 numbers, right? The number in front of x, that's the slope. The number by itself, that's the y value of the y-intercept. So y-intercept is 0, 9/4. All right? Okay, we'll practice more. Next question, yeah, same requirement. We are converting this equation, we'll rewrite the equation in the slope-intercept form. So we are going to isolate the y on the left side. To do that, we move x over. So x is a positive on the left, it's going to be negative on the right, okay? Yeah, we move x over, we have negative x. And then we divide each side by -1, divided by -1, divided by -1. So we have positive y equals x. Do you agree? Yeah, we have y equals x. Yeah, how do we identify the slope and the intercept? And this time, the equation doesn't look like the formula, right? And the formula of slope-intercept form is y equals mx plus b. Yeah, that's the reason is because the constant term is 0, okay? The constant term is 0. Yeah, the reason it doesn't look like the formula is because the constant is 0. Okay, question. What's the x-intercept? Oh, sorry, my bad. What is the slope? What's the y-intercept? Y-intercept. What's the slope? Slope is 1, exactly. What's the y-intercept? Tevin, the intercept is 0, 0. Yeah, same with Desiree. I think I need to address this part more. Yeah, slope is 1, we all understand that. The y-intercept always have 0 as the x value, right? And the second value, the y value, is b equals 0. So y-intercept is 0, 0. Yeah, let me explain one more time. So the slope-intercept form y equals mx plus b, right? Yeah, how do we understand b? B is the second value of the y-intercept. And what happened to the first value? First value is 0. Okay, so the constant b is the y value of the y-intercept. Y-intercept, remember guys, x-intercept, the y-intercept. Y-intercept is the intersection of the straight line and the y-axis. So the y-intercept must be on the y-axis. So the x value must be 0, right? Must be 0. Yeah, thank you, Desiree. So since in this case, number 2, b is 0, so the y-intercept is 0, 0. Earlier in number 1, b value is 9/4, so y-intercept is 0, 9/4. You see that? Okay, I believe it's better. Yeah, the more times we practice, the better you see it. This chapter is kind of interesting. Students either do very well without much effort or does not do very well, even tried. So that is the second question. Now let's look at number 3. Number 3, the equation is, let me get more space. The equation is x plus 2y equals -8. We are going to rewrite the equation in a slope-intercept form, right? So our goal, again, is to isolate the y on the left side. Isolate the y on the left side. So everything else goes to the right. Everything else goes to the right. So keep 2y on the left. Move x over, -x. keep -8. And then we divide everything by 2. Divided by 2, divided by 2, divided by 2. Cancel, cancel. We have y equals, this is -x over 2 is -half times x. Yeah. It might be not very directly to see it, but if you look at it from right to the left, you can see it very well. -half times x over 1 is negative x over 2. So on the right side, the coefficient is -1, and you divide by 2, then the coefficient becomes -1/2, and then variable x. -8 divided by 2 is 4, -4. So the slope-intercept form is y equals -half x minus 4. Let me write a formula right under it. Then you can look at the format better. We didn't write the equation in the slope-intercept form, right? Once we have a y by itself on the left side, on the right side, we have mx plus b. Question, what's the slope? And what's the y-intercept? What's the slope? What's the y-intercept? Slope is -half. Awesome. Thank you, Belle. What's the y-intercept though? 0,94. Thank you, Belle. Very good. 0,-4, right? Do we have this negative sign? The constant is -4. Yeah. Perfect. Thank you, Joe. So the y-intercept is 0,-4. Slope is -half. Yeah, you guys do a lot better. Yeah. So the more practice we do, the better we get. Very good. Number 4. Number 4, the equation is x equals 2. Anybody remember what type of straight line that is? On Monday, we have agreed any linear equation in 2 variables represent a straight line in a rectangular coordinate system. In other words, the graph of a linear equation in 2 variables is just a straight line. And this, you agree this is a linear equation in 2 variables. 1 times x plus 0 times y equals 2. Remember that? Yeah, b is 0. Yeah, it is still a linear equation in 2 variables. Anybody remember what a type of straight line it is? Let me remind you, either horizontal or vertical. Is this vertical or horizontal? Vertical. Awesome. Very good. Thank you. Exactly. Well, vertical. Very good. Question, what's the slope of a vertical line? What's the slope of the vertical line? What is the slope of a vertical straight line? Undefined, exactly, does not exist. Very good. That's the reason this equation cannot be written in a slope-intercept form. Yeah, the slope-intercept form does not exist. The slope-intercept form does not exist. Yeah, we cannot write y by itself on the left side. It doesn't even have a y, right? Okay, and that answered this question earlier when I say we have 2 formats. One is a standard form, the other is a slope-intercept form, right? Yeah. Why did I say that slope-intercept form is the most common used form? However, we define linear equation in 2 variables using standard form. It's because even slope-intercept form has so many advantages. It has one disadvantage. What is the disadvantage? Slope-intercept form does not apply to vertical straight lines because the vertical straight lines do not have slopes. So of course, it does not have a slope-intercept form, right? And the standard form, even the looks more complicated, compared with slope-intercept form, it applies to any straight line. It applies to all linear equations in two variables. That's why we define linear equations in two variables using standard form. Okay, that's the only form applied to all the straight lines. Slope-intercept form is very good, but it does not apply to vertical straight line because the vertical line does not have a slope. Okay, that's number 4. Number 5. Number 5, the equation is y equals -5. Question: what the type of straight line that represents? Y equals -5. What the kind of straight line that represents? Y equals -5. Number 4 is vertical. Does that mean this is a horizontal? And is this already a slope-intercept form? Slope-intercept form is y equals mx plus b. Looks a little bit different, right? Yeah, that's because slope is 0. Yeah, you know this is a horizontal, right? Yeah, this is a vertical. This is a horizontal. Horizontal straight line has 0 as a slope, right? Remember that? So y equals 0 times x plus plus -5, so -5. You see that? Okay, that's the slope-intercept form. Y equals 0x minus 5. You don't have the variable term. Is because the coefficient of x is 0. Slope is 0 because the horizontal, right? Yes, slope is 0. Let me write it down. Slope is 0. And what's the y-intercept? What's the y-intercept? Zero comma -5. Very good. Thank you. 0 comma -5. Perfect. All right. Yeah. One more thing. One more question, number 6. I want to move them. It doesn't let me move. Try this. Okay, I'll just leave that. Number 6. How about let me do number 6 on the OneNote, on my OneNote. I have more space here. Okay. Number 6. Is ax plus by equals c. And we're going to let b be a non-zero value. Okay, b is a non-zero. Yeah, b is non-zero means the line is not vertical. Okay, yeah. So this represents, represents any non-vertical straight line. Okay, yeah, b is non-zero. So it represents any non-vertical straight line. If b equals 0, you don't have this part. You would have x equals a number, and that is a vertical line. And we know vertical line does not have a slope-intercept form, right? Okay. So same thing. Our goal here, is to rewrite the equation in the slope-intercept form. So we are going to isolate the y on the left side. Isolate the y on the left side. Then we're going to move everything else to the right. Move ax over. We have a negative ax, and then plus c, right? Since b is non-zero, we are able to divide everything in the equation by b. Divided by b, divided by b, divided by b. And b over b is 1. So we have a y equals negative a over b times x plus c over b. And that's the slope-intercept form of this equation. Okay, question, what's the slope and what's the y-intercept? Slope is, be careful with the sign. Yeah, the sign is pretty important. Be careful with the sign. What's the slope? Let me write a formula under, then you can compare. Slope is negative a over b. Very good, very good. And awesome, thank you, Joe. And Tevin have the both correct. Very good. So the slope is, yes, right here. Slope is negative a over b. And the y-intercept is 0, comma c over b. Okay, yeah, you don't have to worry about the y-intercept, but this is a formula I want you to memorize. If we have a straight line is written in the standard form ax plus by equals c, then the slope of the line is going to be negative a over b. Is a formula that I want you to memorize. Just now, we actually proved this formula. Yeah, we actually just proved the formula, okay? Yeah, number 6, if we have a straight line in the standard form ax plus by equals c, then the slope is negative a over b. Of course, b has to be non-zero, right? Otherwise, it's going to be vertical. Slope is slope does not exist. Okay, this is a formula that I want you to memorize. This is a formula I want you to memorize and use. What happened is, if we have the straight line in the standard form, and ax plus by, a is the coefficient of x, b is the coefficient of y. Yeah, all you need to do is to put a on the top, b on the bottom, make a fraction, and then take the opposite. Okay, the opposite of a over b. Okay, the opposite of a over b. Let's memorize. Remember, we have a formula here because later, after we learn the theorem about the parallel and what is that called? Perpendicular. We are going to use this formula. Okay, we are going to use this formula. Yeah, I can demonstrate a little bit. Let's say we have a straight line 2x minus ay equals 4. I just randomly write this equation. This equation is in the standard form, right? And I can use the formula quickly find the slope for the line. Yeah, even it's not slope-intercept form, and I don't have to do things, convert it to the slope-intercept form. I'm able to identify the slope super fast. Let me show you how, okay? Let me show you how. This is what I do. I firstly identify coefficient of x. Coefficient of x on the top, the blue on the top, over coefficient of y on the bottom, the pink on the bottom. And what I have negative 1 over 4. Okay? But the slope is not negative 1 over 4. The slope is the opposite of the number you just got. What's the opposite of negative 1 over 4? Positive 1 over 4. Yeah, in fact, if you really grasp this technique, you can find the slope super fast. Super fast. So simply use the blue over pink and then flip the sign. Flip the sign. Yeah, we're going to use this formula later. Any question about this problem? Through this example 11, we do two things, okay? Through this example 11, we need to know, we learn two things. The first thing, how do we convert an equation to slope-intercept form? Yeah, how do we rewrite a straight line in a slope-intercept form and identify the slope and the y-intercept from the slope-intercept form? That's the first thing. Second thing is this formula we just proved. If we have a straight line written in a standard form, we have this formula to apply, then we can quickly find the slope. Yeah, I use this method. By the way, you don't have to. I'm not trying to force you have to use this this method. If you don't like this method, all you can do is you just rewrite the equation in the slope-intercept form and identify the slope. Yeah, either way would be good. Okay. Yeah, it's just for me this is very convenient. As I can see, the blue and the pink have opposite sign, right? When the blue and the pink have opposite sign, I know the slope is going to be positive. Okay? Yeah, if the blue and the pink have opposite sign, the slope is going to be positive. Positive what? 2/8. 2/8 is 1/4. Yeah, find your own way to understand it. Find your own way to memorize. And now let's move to example 12. I assume you have no questions? Yeah. Ask yourself, are you able to convert an equation to the slope-intercept form and identify the slope and the intercept? Yeah. Are you able to, at least be aware we have a formula here to find the slope? Yeah, let me know. Do you have any questions? Joe do you have a question? Joe, can you shoot a question? No question. Okay. Thank you. All right, let's move to number 12. What do we do for number 12? Number 12, we are going to learn a theorem. We are not going to prove it. We just need to know what it is. We don't care about why. Yeah, we just know what and how to use it. So this is the theorem, okay? Let's say L1, L2 are straight lines, okay? Yeah, because L is the initial of the word line. And the slope of L1 is M1. Slope of L2 is M2. Yeah, we use M1 to represent the slope of L1, M2 to represent the slope of L2. Okay, that's something we need to take care of notation-wise. Here come with the conclusion. Yeah, L1 is parallel to L2 if and only if M1 equals M2. I'll explain later, okay? That's the first conclusion. Second conclusion, if L1 perpendicular with L2, then M1 times M2 equals -1, vice versa, okay? Vice versa. Yeah, so here we have two conclusions, or two parts in a theorem, and those two parts do not exist, do not hold at the same time, okay? Yeah, so the basically two conclusions, okay? They have nothing to do with each other. Let me explain. The first conclusion about a parallel. You see this notation? This notation means parallel. Okay, so when we drive, let's say we drive on the road. Let's say the road are straight, not curved, and the line, the white line or the yellow line, frame the lane. Those two lines must be parallel. Otherwise, you crash. Okay, yeah, they must be parallel. Two straight lines are parallel means they never cross. Okay, they never cross. So in algebra, How do we know if two straight lines are parallel without looking at the graphs? If we look at the graphs, the two straight lines they never cross, right? But in algebra, how do we know the two straight lines are parallel? Two different lines parallel. If they have the same slopes, okay? If they have the same rise over run, if they have the same steepness. So this is the condition for a line, for two straight lines to be parallel. And vice versa, if we know, so the both direction, okay, this means if and only if. Means from left to the right, left implies right, right also implies left. So it says if two straight lines are parallel, then they have the same slopes. Vice versa, if the two straight lines have the same slopes, then they are parallel. So that's the first conclusion, okay? Yeah. I want you to memorize because we are not proving it. So you would have to memorize the conclusion. Knowing what is parallel first, and then knowing the condition for two straight lines being parallel is their slopes are equal to each other. They have the same slopes, right? Yeah, same rise over run, same rise over run. That's the first conclusion. I do not worry about that. The second conclusion is the challenging one. And this notation means perpendicular. Perpendicular. Yeah, two straight lines are perpendicular means what? Means the two straight lines cross, not just cross, the angle formed by the two straight lines 90 degrees. Okay, that is called a perpendicular. Perpendicular. If it's not 90 degrees, then they are not perpendicular. It has to be exactly 90 degrees. So we have a perpendicular everywhere, right? When we look at our phone, when we look at our computer, rectangles are everywhere. And the two adjacent sides of a rectangle is perpendicular because they form a 90-degree angle. All right? Yeah, perpendicular. So in algebra, how do we know if two straight lines are perpendicular? This is the condition. This is the condition. Very important. Okay? Yeah, very important. How do we understand that? Let me explain. Either you memorize m1 times m2 equals 91. The product of the two slopes is 91. When you multiply the two slopes, you get 91. Or you remember this. The two slopes are opposite reciprocal. Okay? This is the concept. We're going to have a new concept. And the number 13 is to prepare us for the second conclusion, the perpendicular thing. And is to help us to understand what is the opposite reciprocal. Yeah, we understand what is opposite, right? We understand what is reciprocal, right? And then what is the opposite reciprocal when we put them together? Let's practice number 13 and then we go back. Okay? Three concepts. The last one is a new one. The first two, they are, not new. Let's recall what is opposite. Two numbers are opposite. If two numbers are opposite, they have opposite sign, okay? They have the same absolute value, but they have opposite sign. The opposite of positive is negative. The opposite of negative is positive. But reciprocal is different. Reciprocal is interchanged numerator and denominator. Two numbers, they are reciprocal, then their numerator and denominator are interchanged. But they must have the same sign. Okay, if both of them are if the number is positive, the reciprocal is also positive. If the number is negative, the reciprocal is also negative. Okay, the sign doesn't change. Opposite, you change the sign, but reciprocal, you do not change the sign. You interchange the top and the bottom. Okay, question. Help me to answer those questions, okay? As you can see this table, let's fill in those blanks. The first number given is 3/4, Anybody help me to identify the opposite? What's the opposite of 3 over 4? Isn't it negative 3 over 4? Awesome, perfect. Negative 3 over 4. Good job, Tevin. All the three answers are correct. Thank you, Jill. Your answer is correct. Very good, perfect. Is it negative 3 over 4? And what's the reciprocal? What's the reciprocal of 3 over 4? The reason I want to put them together, make the table to explain, is because this is a common mistake. People confuse one with the other. Yeah, that totally understandable. Exactly. Thank you, Amanda. Because we don't really, how often we use those things in reality. And it's good already, not bad already. You know there's something opposite. There's something called a reciprocal, right? Yeah, it's totally normal that you confuse one with the other. So yes, reciprocal, you interchange the top and the bottom. The reciprocal of 3 over 4 is 4 over 3. Then what is the opposite of reciprocal? Is you change the sign and interchange the numerator and denominator. You combine both. Yeah, combine both process. Yeah, the opposite reciprocal. So you take the reciprocal and then you change the sign. Am I clear about what is the opposite? Yeah, exactly. Thank you, Amanda. Am I clear about what is? Yeah, thank you, Jill. Perfect. That's clear. Okay, now I'm gonna do the rest of 3. Okay. Yeah, agree with me if you don't understand or you don't disagree. If you don't agree one answer, just let me know. -2. The opposite of -2, positive. Yeah, very good. Reciprocal of -2, -12. Yeah, let me know it to see. Ask yourself if you got the same answer. Yeah. And what is the opposite reciprocal? Positive half. Okay, positive half. The sign is different. The given number is 92, so the opposite reciprocal is positive. Yeah, 92 and a positive half. Change the sign of the reciprocal. And 5, opposite of 5 is 95. Opposite of 5, reciprocal of 5 is 1 over 5. Opposite reciprocal, negative 1/5. Okay? The last one. The given number is negative 2/3. The opposite is going to be positive 2/3. Reciprocal is going to be negative. Reciprocal does not change the sign, by the way. Again, negative 3/2. Opposite reciprocal, positive 3/2. Okay? Yeah. Any questions about this table? Any question about this table? Okay, awesome. Yeah. Now let's look at here. I want you to look at the multiplication of the number and its opposite reciprocal. Yeah, what's the multiplication? Like you multiply them together. What's the product of 3 over 4 and -4 over 3? What's the multiplication equal to? If you multiply 3 over 4 with -4 over 3, what do you have? You can use the butterfly method. -1. Thank you, Amanda. Perfect. And if you multiply -2 with its opposite reciprocal, what do you have? You multiply -2 with half. Yeah, -2 times positive half. Would you still get a -1? If you multiply 5 with its opposite reciprocal, -1 over 5, you should get a -1 again. Okay? Yeah. If you multiply -2 over 3 with its opposite reciprocal, you got a -1 again. Yeah. So if two numbers, they are opposite of reciprocal of each other, the multiplication of them is -1. Vice versa. If two numbers multiplied to -1. That means then the two numbers are opposite reciprocal of each other. Okay, I think we should be okay with the new concept, opposite reciprocal. And that is the condition for two straight lines being perpendicular. Okay, yeah, in algebra, how do we know two straight lines are perpendicular? If we multiply the two slopes, if we multiply the two slopes, we got a -1, then the two lines are perpendicular. Or if we are able to identify the two slopes are opposite reciprocal, yeah, the two slopes are opposite reciprocal, then we know the two straight lines are perpendicular. Yeah, the other direction also holds. If the two straight lines are perpendicular, then the two slopes are opposite reciprocal of each other. The two slopes multiply to -1. Okay. Again, the two conclusions need you to memorize. I believe after we do number 13, at least you have a pretty strong impression about the conclusion number 2. Conclusion number 1, I don't think you need to make much effort to memorize. Yeah, the problem is number 2. But after we practice this, you should at least have some impression about the condition. Yeah, opposite reciprocal. Opposite reciprocal. Okay, now we are going to use the theorem. We are going to use the theorem to determine if the given two straight lines parallel or perpendicular or neither. Okay, yeah, let me do 2 and then you help me to do 2. I'm going to do the first two. My method, I'm going to use the formula we have just proved. What formula? Yeah, why do I use that formula? It's because I see this equation, this straight line is in a standard form. This is also in a standard form. And since I'm determining the goal here, my task here is to determine if they are parallel or perpendicular or neither. So I need to know their slopes, right? Yeah, if I know their slopes, I would be able to determine. Yeah, because if the two slopes are equal to each other, the two straight lines are parallel. If the two slopes are opposite reciprocal, then I know the two straight lines are perpendicular. If neither, then neither. So in order to determine in order to answer the question, we need to know the slopes of the two straight lines. Okay, in order to know the slopes, the technique I use, you don't have to use the same method, but I use this method. I use the formula. We proved this formula earlier. I use the formula -a/b. Okay, I can use the formula very quickly to find the slope for the two straight lines. Okay, let me show you how do I do that. So this is straight line, x plus 3y equals 5. So we know a is 1, b is 3, right? We know a is 1, b is 3. Correct? Since a and b both are positive, yeah, they have the same sign, I know the slope is going to be negative. -1/3. Yeah, negative a on the top, b on the bottom. Let me know, am I clear? Let me know if I'm clear or not. A goes to the numerator, 1. B goes to the denominator, 3. So I have a 1/3. But I take the opposite because the slope is negative a over b, right? And let me know, am I clear? I went fast because the technique is very fast. Give you the result. Or if you need me to do it again, also let me know, please. No reaction? No response? Okay, thank you, Belle. And let me do the second one. Okay, the second one A is -3, B is 1. Yeah, A and B, they have opposite sign. Yeah, if you understand this formula, you know if A and B have opposite sign, the slope is going to be positive. The slope is going to be positive. Positive what? Now I know it's positive, right? I don't have to play the sign anymore. I know it's positive. Sorry, A goes to the top. Yeah, the absolute value of A goes to the top, B goes on the bottom. So 3. Slope of the second line is positive 3. Okay? First slope, -1/3. Second slope is 3. And are they parallel or perpendicular or neither? Yeah, I got the slopes for you. Then we should be able to determine, are they parallel or perpendicular or neither? Let me remind you, if the two slopes are equal to each other, parallel. If excuse me, if the two slopes are opposite reciprocal, or you multiply them together, you get -1, then they are perpendicular. Exactly. Thank you, Bell and Joe. They are perpendicular, right? They multiply to -1, and they are opposite reciprocal. Opposite reciprocal. Perpendicular. And by the way, for finding the slope, you don't really have to use this method if you don't like it. For example, for -3x plus y equals 3, how do you know the slope of the line? You can convert the line, you can rewrite the equation in the slope-intercept form. You can move -3x over, you got a positive 3x plus 3. Okay, compare with the formula, y equals mx plus b. Your slope is 3, right? Yeah, there are different ways to get that done. There are different ways to get that done. So slope is 3. All right. Number two. I notice this equation standard form, this equation standard form again. Okay, I'm gonna use my method again. So I'm going to this M1. I know A is 4, B is -1. Yeah, A and B have opposite sign. If A and B have opposite sign, I know the slope is going to be positive. It's going to be positive, okay? Yeah, so positive what? Absolute value of A go on the top, absolute value of B go on the bottom. So slope of the first line is 4. Slope of the second line, A is 8, B is -2. Yeah, they have opposite sign, so I know the slope is going to be positive. And absolute value of A go on the top, absolute value of B go on the bottom. So 8/2 is 4 again. Okay, first equation, slope is 4. Second equation, slope is 4 as well. Yeah, when you have both of the slopes equal to 4, parallel. Awesome. Exactly. Okay, yeah. So let me spend time here. I want to show you why they are parallel. The first equation, 4x minus y equals 4. If we isolate the y on the left side, rewrite the equation in the slope-intercept form, we have -y equals -4x plus 4. And then divide by -1, divide by -1, divide by -1. And y equals positive 4x minus 4. So that's the first equation, okay? And second equation, 8x minus 2y equals -12. Yeah, we move 8x over, we have -8x and then minus 12, and then divided by negative 2, divided by negative 2, divided by negative 2. We have y equals 4x, negative 8 over negative 2 is 4. And then negative 12 divided by negative 2, positive 6. And that's the second equation, okay? Yeah, look at the two equations in a slope-intercept form. Look at the two equations in a slope-intercept form. Slope-intercept form, y equals mx plus b. Y equals mx plus b. Yeah, obviously, they have the same slopes, right? And they have different intercepts. Yeah, so they have the same slopes but different intercepts. That make the two straight lines parallel. All right. Okay, please do number 3 and number 4 on your own and share your answer. I give you 3 minutes. It's 18, 7, 18. I'm gonna go back to you in 3 minutes. You can use whatever the method you feel comfortable, okay? You can use the formula here to find the slope, or you can rewrite the equation in a slope-intercept form and then identify the slope and then identify the value of the slope. Either way is good. Okay, I'll give you 3 minutes. Okay, let's see. Number 3, you know my method, I can identify the slope right away. That's the reason I want to share it. If you like to really make effort to learn the method, I can write the slope right away. And that one is 2. And this one slope is 5. This one slope is 1/5. Yeah, my method is, as you can see, if you really grasp the method, you can get it done so fast. Yeah, 4, 3, negative 4, 3, negative 4, 3, 2, 1, because they have opposites, so slope is positive. 2, 1, 2. And this one is 5 over 1, positive. This one is 1 over 5, positive. Number 3, neither. Number 4, okay, let me see. Number 3 is neither, I agree. But could you look at number 4 closer? Can you look at number 4 closer? Are they opposite reciprocal? Yeah, they are just reciprocal. They are not opposite reciprocal, right? Huh? Oh, sorry. Huh? It's not, right? Guys, are they opposite reciprocal? They are not. Yeah, they are not. Okay, English is confusing. Yeah, they are not. No, they are not. Okay. First line has slope 5. Second line has slope 1 over 5. The two slopes are not opposite reciprocal. They are reciprocal. Reciprocal does not give us perpendicular, okay? They are not. Yeah, slope with 5 is very steep, and 1 over 5 is very, very mild. Yeah, but they do not have a 90-degree angle. They are not. The reason they are not because they are both positive. Okay. You can try. Only when the two slopes have opposite sides is it possible for them cross with 90 degree. If they are both positive, that means there's the angle has to be less than 90. Has to be less than 90. Yeah, so the number 4 is also neither. Number 4 is also neither. Okay, very good. Perfect. Any question about number 14? Use the theorem to determine if the given pair of lines parallel or perpendicular or neither. In order to answer that question, we need to know the slopes. Yeah, there are multiple different ways we can apply to find the value of the slopes. Right? Okay, so if you have no question, I'm going to move to number 15. Okay, remember I forecast. I mentioned there are three forms. There are three forms for linear equation in two variables. Linear in this chapter, equations, linear equations in two variables. Graphically speaking, those linear equations in two variables are straight lines. And we have three different forms for linear equations in two variables. The first form is called the standard form. It's ax plus by equals c. A, b not both zeros. Second one is we learned today, slope-intercept form. So the formula is y equals mx plus b. Here, m is the slope, 0b is the y-intercept. That's the reason it's called slope-intercept form. And number 3 is we are going to learn the third form. It's called a point-slope form. Point-slope form. Yeah, as the name shows, in the equation, we have a point and a slope. Yeah, let me show you what's the formula. Y minus y1 equals m times x minus x1. All right? Yeah, this is the point-slope form. Point-slope form. In the equation, x, y, of course, are the two variables, right? And what happened to x1, y1, and m? M is the slope. M is the slope. x1, y1 is any point on the line. Oops. Any point on the line. Yeah, that gives a special characteristic of point-slope form. Point-slope form of a straight line is not unique. Is not unique. Yeah, the point could be any point on the line. How many points do we have on a straight line? We have infinitely many. So yeah, we actually could come up with infinitely many different point slope form for one straight line. Yeah, again, slope-intercept form is the most commonly used format. Is because for a straight line, slope-intercept form is unique. Yeah, even standard form maybe not unique. Depends on you can actually modify. Yes, standard form is not unique. Only slope-intercept form is unique. Point slope form, the point could be any point as long as the point is on the straight line. Okay? Yeah. Here the blue x1, y1. Let me write it as blue. X sub 1, y sub 1 is a point on the straight line. Okay? And I want to color them. This is yellow. I want to explain the structure. How do I understand the structure of the point slope form? Okay, let me explain. Look at the purple. Look at the purple I just shaded. It's in the parentheses, right? In the parentheses, we have variable x plus a number. I'm using adding, okay? Yeah, we have a variable x plus a number. And what's that number? And that number is the opposite of the first component of the given point. Yeah, just the opposite. And look at the yellow. On the left side, we have a variable y plus a number in yellow. And what's the number in yellow? The number in yellow is the opposite of the second value of the given point. And then m is right here in front of the parentheses on the right side. So y is on the left side, x is on the right side in the parentheses. Yeah, this part is x plus number. What's the number? That number is the opposite of the x value of the given point. On the left side, variable y plus a number. What's the number? That number is the opposite of the y value of the given point. Do you see the structure, guys? Instead of saying minus, I say the opposite plus the opposite. There's a benefit of doing that. Of course, the best way to understand that is to use it. Okay, let's use it. Yeah, what's the point slope form of linear equation in two variables? It is this: y minus y1 equals m times x minus x1. Yeah, since the point slope form also involves slopes, point slope form does not apply to vertical straight line. Has to be non-vertical straight line. So x1, y1 is the point, any point on the line. M is the slope. Okay, is the slope. Okay, let's use it. Yeah, only when we use it we can reinforce. Number 16. Number 16 and number 17 is to get familiar with the formula. Okay. Number 16, we are given a point, we are given the slope. We are writing the equation in the point slope form. Yeah. So the name of the form is a point slope form. That means if we have a point, if we know one point on the line, and we also know the slope, we determine the line. The line is determined, and we should be able to find the equation. Okay, let's try that. Let me show you how do I do it, okay? Let me show you how do I do it. I use the formula. On the left side, I have a variable y plus a number, and that number is the opposite of the y value. What's the opposite of the y value? Y value is -2. The opposite of it, +2. That's left side. Equals On the right side, I have the slope as the coefficient of the parentheses. In the parentheses, I have x plus number. I have x plus number. Plus one number. The number is the opposite of the x value of the point. The x value of the point is 1. What's the opposite of it? Is -1. That's how do I do it. Instead of using minus negative really throw people sometimes. So I use opposite. You need to know what is opposite. All right, guys? Let me know, am I clear? Yeah, I start from the left side. Left side, variable y plus number. What's that number? That number is the opposite of the blue. The opposite of the blue. On the right side, I have slope times the parentheses. In the parentheses, I have variable x plus number. And what's that number? The number is the opposite of the pink. The opposite of the pink. Okay, guys. Either ask question or work on number 2. Number 2 is yours. You should be able to type. It does have a option though. Yeah, either let me know that if you have any questions about number 1, or please work on number 2. What's the point slope form of the line? Point is given, slope is given. Y, let's see, y plus 0 or minus 0 doesn't matter because 0 equals on the right side positive half times parentheses x plus 3. Awesome. Very good. Very good. Perfect. Exactly. Your answer is correct. It is y minus 0 or plus 0 doesn't matter, right? Yeah. Or even you don't have it, it's okay. Yeah. Plus 0 minus 0 equals half times parentheses x plus 3. Yeah, let me tell you the common mistake is we start from y on the left. Common mistake is there are students, they start from x. You know, in your y value is the blue, the second value. Your x value is the pink, the first value. Your x value is on the right side. Your y value is on the left side. Perfect. Number 17 is the other way around. Number 16, we are given a point and the slope. We are looking for the point slope form. Number 17, we are given the point slope form. We are looking for a point, the point, and the slope. So we are doing the opposite. So point, slope. And this one, point, slope. Yeah, doing the opposite, right? Yeah, let's see how do we do that. I was worried about doing a plus 3. But I had that answer. What is a, Joe? Like Tevin? Yeah, x plus 3. X. We have to use x and y as the two variables in the equation because we are studying the equation in the rectangular coordinate system. In the rectangular coordinate system, the two axes are x and y. That's the reason we use x and y. Yeah, Tevin's answer is correct. That means your answer is correct as well. Okay. All right, guys. Number 17 is the opposite. All right. You are given the point slope form, and you are identifying the point and the slope. Number 1, y plus 5 equals negative times parentheses x plus 6. Yeah, what's the slope? The slope is the coefficient of the parentheses on the right side, right? Yeah, what's it? What is it? -1. Awesome. Thank you. Perfect. Thank you, Amanda. Yeah, -1. Perfect. And what's the point here? Yeah, doing the opposite. All you need to do is the opposite. Look at the blue. This is the pink. Pink. And this is the blue. Blue. Right? And the point, I'm going the x-axis, the x value of the point is the opposite of the blue, the opposite of the blue, so -6. And the y value is the opposite of the pink, so -5. You see that? Yeah, -6, -5. Again, you start from the blue. You start from the blue, and then you go to the pink. Blue is on the right side. X value is on the right side. Y value is on the left side. Yeah. Okay. Can you help me to find the slope and the point for number 2? Yeah, number 2 is a little bit weird, right? Yeah, number 2 is y equals x minus 1. Let me help you out. This actually is also slope intercept form, but you can modify. You can do this. You can modify it, right? They are the same. And once I modify it, it's the point slope form. So what's the point and what's the slope? Slope is 1, correct, Amanda? Very good. And what's the point? Yes, slope is 1, very good. And what's the point? The blue is this. The pink is this. One comma 0. Awesome. Exactly. 1 comma 0. Perfect. 1 comma 0. You guys are great. Perfect. All right, so the number 17, number 16, number 17 is to get us familiar with the point slope form. Number 18 are challenging problems. Let's see how many minutes. We have 9 minutes. Let's do one. Let's do the first question in number 18. Okay, I'm going to slow down, and I'm going to only use one method. Sometimes I feel like if I teach too many different methods and people get confused. How about let me just spend time to do one method. Let's read the question first. This question, we're looking for the equation of a straight line. Okay, in the slope intercept form. That means we have to write the line in the slope intercept form. Slope intercept form looks like this. And we know the line passing through 6, 5 and parallel to 5x minus y equals 9. Yeah, that's the information we know. One piece of information, I'm going to highlight it in yellow, passing through this point. Another piece of information, I'm going to highlight it in green. A parallel to that equation, okay? Yeah. So the 3 forms we have learned so far, we only learned three forms. The 3 forms we have learned about linear equations in 2 variables, they are standard form. The other 2, point slope form and slope intercept form, both of the two forms involve slope. So seriously, we have to find the slope. Do we have the information that we can use to find the slope? Yes, the green piece give the information. Okay, when you think about parallel, perpendicular, that involves slopes, right? Okay, let me show you how do we use the green condition to find the slope of the line. Yeah, let's say the L is let's say the line is L. Yeah, let L be the line. Let L be the line we are looking for, and the slope of L is M. Okay, it's just for convenient later when I explain. Now I'm gonna start. Since L is parallel to the green 5x minus y equals 9. Yeah, let me highlight it in green. Yeah, the condition says the line we're looking for is parallel to the green straight line. Yeah, since they are parallel, we know the slope of the two straight lines. What happened to the slopes? If we know two straight lines are parallel, what happened to their slopes? If we know two lines are parallel, what happened to their slopes? Hello? Equal. Oh no, they are equal. Yeah, equal to each other. A vertical line has undefined slopes. Yeah, equal to each other. Remember that? Let me go back. The theorem we have learned. Yeah, you got it now. Yeah, I have to get a terms. Yeah, the terms is right here. If two lines are parallel, then they have the same slopes, right? Yeah. So the given information says the two lines are parallel, so they have the same slopes. They have the same slopes. And anybody can tell me what's the slopes of the green. Yeah, I'm gonna ask you to do that. So the slope of L equals the slope of 5x minus y equals 9. Yeah, the green equation is in the standard form. Anyone would like to help me to find the slope of the green? Anyone would like to help me to find the slope of the green? Any method would work. You either use the method, use the formula, slope equals negative a over b, or you can rewrite the equation in the slope interceptor form and identify the slope. Yeah, what's the slope? 5, positive. Yeah, let me show you why it's positive. Because 5x, let me use a different way. 5x minus y equals 9. This time, I'm going to move negative y over to the right. It becomes positive y. And then keep 5x on the left. And then move 9 over, become negative 9. And then I switch the left side and the right side. I have y equals 5x minus 9. Slope is a positive 5. Slope is a positive 5. Sometimes it's confusing, yeah. So we're gonna be very careful, even just tiny bit different. Because if you go to test, go take your test, all that matters is you enter the right answer, right? Even you know part of it, I'm not able to give you the partial credit. I don't have the energy to look over your scratch paper. So be careful. I cannot stress that more. I thought we isolated the y. Yeah. Let me show you again. Yeah, we are isolating y. I'm just playing a different way. So 5x minus y equals 9. Let's isolate the y on the left side. We move 5x over, right? We have negative 5x plus 9. However, we isolate the y means the y need to have coefficient positive 1, cannot be negative 1. So we have divide by negative 1, divide by negative 1, divide by negative 1, right? And then we have y equals negative 5 over negative 1 is positive 5 minus 9. Okay, perfect. So it's a positive 5. So now we know the slope of the equation we are looking for is 5. It's 5. Very good. We're making good progress. Yeah. So now I'm going to use the method. Let me finish this and then we go. Okay. Yeah. So since we're looking for the slope in the seventh form of the equation, and I can write the equation, then let the slope in the seventh form of L be y equals mx plus b. Okay. Yeah. Then the slope in the seventh form of L is y equals 5x plus b. Y equals 5x plus b. Because y equals mx plus b. M is found, is 5, right? Okay. Now I'm going to do the second part. We have another piece of information in yellow. Okay. Since L passes through 6, 5, x equals 6, y equals 5, satisfy y equals 5x plus b. Yeah, since 6, 5 is on the line, so 6, 5 is a solution of the equation. That means if we plug in x equals 6, y equals 5, we're going to get a true statement. So let's do that. We plug in y equals 5 here. We plug in x equals 6 here. And the only unknown in this equation now is the b. So 5 here, 5 times 6, 30 here. And what's the value of b? B has to be negative 25 in order to satisfy, right? Yeah. B equals negative 25. So the slope-intercept form of the straight line L is going to be y equals 5x minus 25. And that's the solution. Okay, we passed 50. We passed the time. I'm not going to elaborate more because next time when we see number 2, gonna be similar. Most of the parts gonna be similar. Okay, so today is Wednesday 13, and next week is a spring break. I'm going to see you on the 25th. Wow, that's in 12 days. I'm gonna miss you guys. Have a very good spring break.
Have a good spring break.
And also, yeah. And also, if you are behind on your assignments, if I were you, I would use the spring break to catch up. Okay? Yeah, have a good night. Have a good spring break. Bye-bye, guys.
Was my attendance marked as attending since I logged in late?